So here's a basic overview of the hydraulic system. You have on the 737, you have system A. Let me just get my mouse working. Here we go. System A, system B, and the standby system. Okay, as you can see, system A has a engine-driven pump and an electrical motor-driven pump. System B has an engine-driven pump, an electrical motor-driven pump, and the standby system has an electrical motor-driven pump. So the idea of the hydraulic systems is that we enable hydraulics to be supplied to all the users at all given times, and some single operations for sacrificable things like spoilers, for example. Others are must use items, therefore they're duplicated, and some are even triplicated. Okay, so this is the general layout of the system. I also have a power transfer unit. You'll see a lot of commonalities here, commonalities in name only. Okay, so those of you that have a 320 training, you'll have seen the power transfer unit in another concept. This one exclusively is one-way traffic from system A to system B for the leading edge flaps and slats. That's its sole purpose in life. Okay, so there's a bit of a difference there. You also see if you have a Boeing wide body, they call them the left, right, and center. Okay, and Airbus usually use colors, yellow, green, yellow, blue. These guys use system A, system B, and standby. The flight deck controls and indications. We already saw this panel in previous explanations, but we'll just go through it. The idea of these are that once the switches are switched on, the flight crew forget about the hydraulics until after the second engine is shut down. So you switch these on and forget about them. The engine ones are already on. So this is the situation when the aircraft is stopped at the bay. This is what it looks like. The engine ones are on. Because the engine's not running, they're not running either. The hydraulics. Okay, so the electric ones are off and have to be switched on electrically by this switch. Okay, and we have indications for all the 4 different pumps. This one we said, okay, is for the standby hydraulics system. Okay, we did say when we're using this panel, it's area for concern because we're using the standby systems. Okay, and if the standby hydraulic is low quantity or low pressure, or the standby rudder is on, then we have to be notified by an amber light, or the pilot has to be notified by an amber light, because that's bad news. Okay, and the hydraulic quantities and pressures are indicated on the system display here in the cockpit. There's a 76% is the threshold where refill is required. Therefore, because he's 75%, he's now refill. RF is for refill. So servicing of the B system has to be performed. System A, and you can see in the presentation it says that the hydraulic system B is almost the same. Okay, there, and it is almost the same, and we'll just talk briefly about this one. We will talk about system B as well. Just have a look at all the components. We start with a reservoir, so system A reservoir, and if you look at the legends, okay, we have a pressurized tank with air from the pneumatic system pushing the liquid down to prevent cavitation and everything. Then the black dots, the supply. Okay, so the supply goes to the engine-driven pump and to the, where's my mouse gone? There it is. And to the electric motor-driven pump. Okay, and then it comes out as high pressure 3000 psi from the engine driven pump and the electric motor driven pump to a system A pressure module, or if you want to call it a manifold. Okay, so this is where all the hydraulics is concentrated here and then gets diverted to the users. Which are the users? The PTU motor, the thrust reverser, okay, the landing gear, the brakes, the flight controls, and the autopilot, aileron servo. Okay, so that's how it goes. And then once it's been used, it returns. You can see the white little dots here to this filter return module. Okay, and returns to the tank. I also have from here a return from the motor driven pump, and I circulate through these through the wings these system heat exchanger. In the wings we have these heat exchangers, which we'll talk about in a minute. Okay, that's basically the layout of system A, the indication of system A, and the indication here. The fire, what has this got to do with hydraulics is that if there is a fire and you actually pull the handle to stop the users or the system, the services, one of the services is hydraulics. Okay, so a engine fire shuttle valve will operate, here it is, this one. Okay, so electrically, the system A, engine driven pump supply shuttle valve will cut the supply, okay, and will not allow hydraulics to go further than here. Okay, the electric one will operate, but the engine one will be shut off. As we said, these are the controls. So for system A, we have this side. For system B, we have this side. We have an overheat for the electric pumps. All right, there's no overheat for the engine pumps because they're attached to the engine. They're in a very cold area. They're not supposed to overheat. Okay, but all four pumps have an amber indication for low pressure because that is an issue. And we said the fire engine APU fire control panel is responsible for when you pull the respective handle on the respective engine, then you will operate that engine fire shuttle valve and the hydraulics will be cut off from the engine. Okay, here are some more components and where they actually live. So the engine driven pump is, funny enough, on the engine. The engine driven pump case drain filter module is also on the engine. And this is that heat exchanger. So what it is basically it's a solid box, a container where we put in the hydraulics, the fluid, all right, and pass it through like this several times and bring it back out again. And this will effectively cool down the hydraulic fluid because it's in the cold fuel. And by default, it will actually warm the fuel up as well. So it kills two birds with one stone. It's a standard maintenance practice on most Boeings. Okay, even the 777 has the same thing. Okay, other components, you can see here the main culprits are in the wheel well, because that's where the hydraulics is basically the reservoirs where everything begins. So you've got reservoir A, reservoir B is a little bit bigger. All right, so each reservoir, each system has its own components, which we just talked about here and here. So system A, this is its exact location in the wheel well. Okay, we're now looking forward. Okay, so if you stick your head in the wheel well, see these are the circles where the wheels are, where the aircraft is flying. So you're in the wheel well now, and you're looking forward, and on the forward spar. So this is the wing spar, the wing box, center tank. Okay, will be the the two reservoirs, system A and system B. Air pressure, we said they're air pressurized, so we pre-charge it. And we also have methods to monitor the quantity as well. We pre-charge it to prevent cavitation, and the pre-charge pressure is around about 50 psi. See that green band? There it is, how the pre-charge works. So from a pneumatic system, we have on a normal aircraft 3 pneumatic systems, one from the APU bleed valve, one from the engine HP valve, and one from the other engine HP valve, and they can at any time supply the amount of air necessary, that 50 psi, which will then pressurize as a pre-charge the reservoirs, okay, to keep the liquid down for any movements of the aircraft that it might be making, and also to prevent cavitation. It provides a constant flow of fluid without any air gaps or any deficiencies in the flow rate that could cause problems with the end users. Okay, here you can clearly see the standby system reservoir. Okay, it's on this stand pipe. Okay, so the way it's constructed, this one doesn't need to be pressurized because it's always, the stand pipe is always under the level of fluid. Okay, that means that this standby system reservoir is always full because this is the last resort. The standby system reservoir is the last resort hydraulics. We'll see later on why. We can also pre-charge through a service cart with nitrogen if we prefer to do so through this air charging valve on a manifold assembly through this it's a normal Schrader valve. All right, here are the tanks again and the difference between them. System A is round about, well, directly in the center. System B towards the right, and system B is larger because it has the fill and balance line to the standby reservoir there. And you can see all the components, a quantity transmitter, an indicator for indicating the quantity, as well as in the cockpit. If you're doing your walk around, you don't have to go in the cockpit to have a look. You can look at the quantity on the tanks, provided the aircraft is in the right configuration. The flaps and slats are up, retracted, thrust reversers are not deployed, etc., etc. Then the quantities will be more truthful to resemble what is actually the true quantity in the tanks. The engine-driven pump is connected directly to the engine, to the accessory gearbox. Okay, and as the engine turns, the pump turns, the hydraulic pump turns. It's got an electrical connector, and it's got the supply line and the return, and it will run as long as the engine is running. The electric-driven pumps. So here is a Parker electric motor-driven pump. The Parker pump has an internal temperature switch in the to monitor its temperature. This implies that the other one is the temperature switch is external of the pump. So there are two types, two vendors. One is the Parker and the other one is called Vickers pumps. That is the only difference. Both of them produce 3000 psi. Both of them are made to the same standard. It's just two vendors supplied Boeing from day dot. Actually, first there was the one, and then the one couldn't produce quick enough, so they engaged another vendor. Okay, and one has its internal temperature switch, and the other one has an external temperature switch. So the temperature switch, the aid of the temperature switch, or the reason for the temperature switch, is to put the overheat light on, as we saw before, the amber indication when it goes above a certain threshold. Okay, so two vendors, remember those, a Parker and a Vickers. Okay, here is the pressure module, or if you want to remember it better, manifold. Okay, so the pressure, the system comes from the hydraulic, comes from the reservoir, goes to the pump, and then concentrates on this pressure module that then gets distributed, okay, to the left reverser, for example, for system A, and to the other users. Okay, and we've got pump low pressure switch monitoring, system pressure transmitters monitoring, okay, engine driven pump pressure switch on system B only monitoring. All right, so you can see there's a lot of stuff going on here, but the main aim is to concentrate the hydraulics, okay, and monitor it for temperatures and pressures, and then distribute it to the users as required. Here are those heat exchangers again. All right, they are none other than we're just passing the hot fluid in the hydraulic pipes, okay, through the cold. This is the center. This is the wing. Okay, this is the fuel tank. So we're passing it, the hot hydraulics through, and then back again. And in that heat exchange, it's a bit of physics. Yeah, we are passing it through a colder material. All right, and inductively. Sorry, we exchange the temperature, or we reduce the temperature of the subject material, and we also by default actually increase the temperature of the fuel, which kills two birds with one stone. Functional description, we already said. We described it sort of halfway. Air pressure pushes down, then the supply goes to the engine driven pump and the electrical motor driven pump and comes out at 3000 psi, where it gets monitored for pressure and filtered, okay, then goes basically to the end users. All right, I also have from system A, as you can see here, goes to my PTU, okay, my power transfer unit, and system A here in this respect supplies system B. Okay, some systems, as you remember, the slats and flaps, we need those. That's the only thing we actually use the PTU for, is for the auto slat deployment when we're approaching a stall, because we really need those slats if we're approaching a stall. This is system A. System B, practically identical, except so you have system A supplying through the PTU system B, and you see it goes through a check valve and then supplies only, look at this, only the leading edge flaps and slats. Okay, because see it goes down to here and then there's a check valve here, it doesn't allow it to go to the other systems, only to the leading edge flaps and slats that are really required in an emergency. Okay, the rest we already saw, the different colors. The supply goes to the engine driven pump and the electrical motor driven pump, and from there we get the 3000 psi out in the system B pressure module now, or the manifold as you want to call it, where it gets monitored for pressure, okay, and then gets sent to the different users. Okay, for ground servicing, the ground servicing takes place inside the wheel well in the right hand area, on the right hand side, in the right hand corner. As you can see here, there's this little arrangement. There's a little a handle here with a hose that gets stowed inside the aircraft. And the idea is there is a fill selector valve where you choose system A or system B, which side you want to uplift. Okay, then you get your can of hydraulic, and then you make a hole in the can or if it's a containerized, the idea is to put this piece of pipe, okay, inside the can, start operating the handle, okay, and pumping out the contents of the can into where you've directed the fill reservoir valve to fill either system A or system B. Okay, that's the whole idea. So you open it from the closed position to system A or system B. And then when you've finished, here you go, this is double action pump. Once you've finished the filling, you then put it back into the closed position. And of course, wherever there's a servicing point, there is always a placard, and it's brilliant. All these placards, take pictures of them, have them on your phone. These are good pieces of information because, yes, we don't remember everything off by heart, but these things never change. The procedure will never change. It even has the reference if you need to go to it. Okay, and will tell you how to do the filling with filling instructions.